Okay, so we're going to look at 3 or 4 equations to balance here. And just a couple things to remember. Most important things are anytime you're going to write a formula, you need to write the symbol of the positive element, symbol of the negative element, both oxidation numbers, and crisscross them down. And we know that we don't crisscross ones and we don't crisscross them if they're the same numbers. So we're going to start out here with ammonium carbonate. So we write ammonium, which is NH4. Carbonate, which is CO3. Ammonium is a 1 plus, carbonate is a 2 minus. So we need to put parentheses around the ammonium and to crisscross that 2. And we're going to react that with, so that's your plus sign, aluminum nitrate. So we have Al, nitrate is NO3, that's a 1 minus, aluminum is a 3 plus. So we need to put parentheses around the nitrate and show there's 3 of those. And that produces, which is our arrow, we have ammonium nitrate over here. And that's a 1 plus and that's a 1 minus, so we don't have to crisscross anything. And we end up with aluminum carbonate. Aluminum is a 3 plus, carbonate is a 2 minus. So we crisscross the 2. We do not need parentheses there, but we do need parentheses here, and there are 3. Okay, so the next thing we do is we start with our T-chart. We've got the left side, we've got the right side. And we have ammonium, NH4, and we can put NH4 because we have NH4 on both sides. So we have ammonium, we have carbonate on both sides, so we put CO3. We have aluminum, and we have nitrate. It's really important to remember that you need to put NH4, not just NH. So we look on the left side, and NH4, we have 2. We have 1 carbonate, we have 1 aluminum, and we have 3 NO3s. On the right side, to begin, we have 1 NH4. Be careful that you don't think there's 4 there. We have 1 nitrate, we have 2 aluminum, and we have 3 carbonate. All right, so now we're just going to start at the top, and we're going to get the ammonium on the right to be 2. So we put a 2 out in front of this whole thing here, and that changes my ammonium to 2. It also changes my nitrate, which was 1, and it changes that to 2. Next, we'll work with the carbonate, and we need to get the carbonate on the left side to be 3. So we put a 3 out in front of this whole thing. Remember, we cannot put numbers in between like that. We can only put them in front of that whole compound. So I'll put the 3 out there, and that changes the carbonate to a 3. That also changes my ammonium, which was 2, to now 6 on the left side. So now the ammonium are messed up, and we already have 2 there. This is kind of a tricky one. We need to go back and we need to get rid of that 2, and we need to make that, now we have, if you look, we don't have 2 anymore. When we erase it, we're back to 1. So we're back to 1, which means if we want 6, we need to put a 6 out there. So that makes that a 6. It also changes the nitrate on that side to a 6. Now to get the nitrate over here to be on the left side to be a 6, we need to put a 2 there. That changes that to a 6, and it changes my aluminum to a 2. And now you look, you have 6 ammonium on each side, you have 3 carbon on each side, you have 2 aluminum on each side, and you have 6 nitrate on each side. And again, your way of checking is to look at up top, each one individually. If we're looking at the ammonium, we've got 3 there times 2 does give us 6. Over here, we've got 6 right there. We have carbonate, we have 1 times 3 gives us 3, and then we have 3 carbonate right here. Aluminum, we've got 2 right there, and we've got 2 right there, and then nitrate, we've got 3 times 2 is 6, and right here we have 6 times that 1, giving us 6. So we know that we do have it correct. Moving on to another problem. We erase this here. For our next problem, we're going to look at how aluminum reacts with hydrogen sulfate. So we have aluminum, which is just Al. Now remember, we do not have Al2 because aluminum is not a diatomic molecule. So we just have aluminum. We can put it to 3+ if we want, but it really doesn't matter because we have nothing to crisscross it with. And we react that with hydrogen sulfate. So hydrogen sulfate is SO4, and hydrogen is a 1+, sulfate is a 2-. So we need to crisscross that 2 right there. That reacts, and we have a single replacement reaction here. So the aluminum is positive, so it's going to end up reacting with the negative sulfate, and the hydrogen is going to be all alone. And the key thing here with hydrogen is it is a diatomic molecule, so if it's all alone, we have H2. And then we have aluminum sulfate. Aluminum, Al, sulfate, SO4. Aluminum is a 3+, sulfate is a 2-. So crisscross the 2 there, and we need parentheses around the sulfate, and we have 3 of those. Now we make our T-chart, left side, right side. Ions we have aluminum, we have hydrogen, and we don't put H2, we just leave it as H. And we do have the ion sulfate, SO4, and we have it on both sides, so we are able to leave that as SO4. We do not have to split it up into sulfur and oxygen. Aluminum on the left side, we have 1, hydrogen we have 2, and SO4, be careful, we only have 1 of them, not 4. On the right side, hydrogen, we have 2, aluminum, we have 2, and sulfate, we have 3. So now let's move on to balance it. Pretty easy to get the aluminum to be 2 over there. So we change that to a 2, and changes that to a 2. And now we've got sulfate. We need to get 3 sulfate on the left side. So we have 1 right now, so we put a 3 out in front there, changes sulfate to 3, but it also changes the hydrogen to 6. We had 2 times 3 gives us 6. Now, the only thing that is not balanced is the hydrogen on the right side. We have 2, we need to make 6, so that's a pretty easy one. We put a coefficient of a 3 out front, and now we have 6. One big thing to remember is aluminum here is not Al2, it's just Al. It's not a diatomic molecule. Where on this side we had hydrogen, which was H2. If that hydrogen was replaced with fluorine all alone, it would be F2. We have N2 as well. We have O2. We have Cl2. We have I2. We have At2. Now we've got 6, 7, and which one am I missing? Chlorine. Nope, got chlorine. Nitrogen, oxygen, fluorine, chlorine, bromine is the one I'm missing. Bromine would also be Br2 if it is all alone. Remember, those are 8 diatomic molecules, so when they're all alone, like you see right here, then you're going to have them written as a diatomic molecule with 2. The last one we're going to look at today is one where we have oxygen on one side as a reactant, and we have it in 2 different spots on the product side. And it's not part of a polyatomic ion on that side either. So when that's the case, what we need to do is we need to stay away from that as much as we can until we are forced to deal with it. So we already have this written out, so all we got to do is make a T-chart and balance it. We have oxygen, we have carbon, and we have sulfur. On the left side, we start out with 2 oxygen, 1 carbon, and 2 sulfur. And on the left side is the tricky part. We have 1 carbon, that's easy. But we have to look here, we have 2 plus 2 oxygen. That gives us a total of 4. So we have 4 oxygen on that side, and then sulfur we have 1. So now, since the oxygen is split up, and you have 2 on It's in two spots on the right side and only one spot on the left side. What we're going to do is we're going to stay away from the oxygen as much as we can, so we're not going to work with the oxygen. We're going to come down here and we're going to work with the sulfur first. So then that's pretty easy. We go over here, we put a 2, and that makes our sulfur a 2. That also changes our oxygen right now. We've got 2 times 2 gives us 4, plus the 2 that we have there gives us a total of 6. So we have 6 oxygen. So now we look over here, and now it's really easy problem. And all we need to do is put a 3 there, and that changes that to a 6. If we had started with the oxygen right away and been working on trying to get this balance first, a lot of times you run into problems where you're kind of going back and forth and you're getting stuck. So anytime that's the case, you want to take a look and try to find out what the problem is, and it's usually best just to start all over at that time.